In example 3.7, we have a function defined. The domain of this function is going to be all real numbers, and we have an equation provided. F of x equals x to the 2/3 plus 3. So looking at the x to the 2/3, if you've been studying your parent functions, you should recognize this as the expression that's used for the bird function. But this is not exactly the bird function because it also has this plus 3 as part of the operation for the equation. So what are we supposed to do with this function? It says find the domain and range of f, that's number 1, domain and range, and state the intervals of increasing and decreasing of f. That's going to be number 2. Well, it is possible to do domain from the equation, but range is really difficult from just the equation. We would have more success if we had the graph. And the intervals of increasing and decreasing are also really difficult from just the equation. So the graph would be the best thing to have. So even though it doesn't say in the example you need to graph the function, because of what's being asked, it points us in the direction of we need to get a graph done. So this example is important because it shows how even though the instruction doesn't say to do something, it might still be beneficial to do the graph to help us to be able to answer the question more appropriately and more efficiently. So graphing at this point, because this is not exactly like the parent function, I think a table approach to get the graph done would be the best way to do this. So let's make a t-chart. The left column will be x. The second column will be f of x. And because it has a portion of the equation with that bird function expression x to the 2/3, I'm going to borrow the x values that we used for the bird function, -8, -1, 0, 1, and 8. Now I understand that the domain of this is all real numbers, so I can pick whatever I want. However, these values I already have previous exposure to, and I know that they are going to turn out relatively nice. So just as a example of how to do this, let me show you one calculation. Let me take f of -8, for example. So that would be -8 raised to the 2/3 plus 3. And remember, with this exponent of 2/3, there's two things that we can interpret this as. We have that 3 representing a cube root, and then we have this 2 representing a squaring function. So just a typical square, raising it to the second power. I typically will like to do the root first and then perform the square. So this is going to be interpreted as the cube root of -8 all squared, and then I'm supposed to add 3. So let me start with the cube root of -8. That would be -2. And then -2 squared will be +4, and then add 3 to that, and I get 7. So -8 is supposed to map to +7. So you can pause the video and go through and do the calculation for the other x values that we've chosen. I'm going to go ahead and complete the rest of the table now. -1 maps to 4, 0 maps to 3, 1 maps to 4, and 8 will map to 7. So as I look at the x's and my f of x values, I see that everything in the second column is positive, and then in the first column I have both positives and negatives, and of course I also have 0 in there. So when it comes to the graph, I don't need all 4 quadrants of the Cartesian coordinate plane. I really only need the first 2. So let me draw a lengthy line here and try to split that in the middle somewhere, because I want to be able to get all the way to -8 on the x-axis. So let me see if I can do that. 1, 2, 3, 4, 5, 6, 7, 8. I can. So there's -8. And when you're making your own graph, it's difficult to make the spacing exact. Do the best you can. We'd have 0 right here in the middle, and I need to put my markings 1 through 8 on the right hand side as well. I'll extend that just a bit. And then in the vertical direction, based on what I currently have in my second column, I don't have anything larger than 7. But with the space I have, I can go all the way to 9. But I needed to go to at least to 7. And there we go. So there's our setup. Let's start plotting points. -8 goes to 7. -1 to 4. 0 to 3. 1 to 4. And 8 goes to 7. So our job now is going to be to connect the dots to make the curve. We should be seeing a pattern that looks really just like the bird function, except we're not going to be using the origin. We're going to be using the point 0,3 to give us the right side, and then from there we'll go and get the left side, maybe. Let's try again. There it is. It looks like that. So it still has that bird function look, and we'll call the graph of this f, but it's just been shifted up by 3. So again, very similar. Let's start answering the questions. Number 1, domain. Well, we already knew the domain because that was given to us back up here in the function definition. The domain is going to be all real numbers. But the range, however, if you analyze the range using the techniques that we've already discussed, you're going to have +3 included, and then any number that is larger than +3 would also be included. So your range would be 3 to infinity. And now we're going to go on to increasing, decreasing. We have a increasing interval, which is taking place starting at 0,3, and it's increasing over here to the right. I don't like that color. Let's do this color here. Increasing from here to here, so that would translate down to 0, and then everything to the right of 0. So I can write increasing from 0 to infinity. Now remember, when you're doing increasing and decreasing, you're always supposed to use open intervals. So you're not going to include 0 in this. It's just not part of the definition for increasing, decreasing. And then for decreasing, we have this interval. And with that interval, that would translate to the x-axis and look like that. So that's going to be interpreted as -infinity to 0.